An electrical stinger usually refers to an underground conduit service that brings power into a building from the supplying transformer. This method is commonly employed as an alternative to overhead service lines. A 400 amp service for a 1977 square foot space suggests a high power demand, typical of commercial restaurant applications. The standard configuration involves a main panel situated near the service entrance, which then feeds power to subpanels located throughout the building. The main panel serves as the entry point for the power coming from the stinger, and it is from this panel that power is distributed to the various subpanels. In situations where the power requirements exceed the capacity of the existing main panel, it becomes necessary to install an additional subpanel. The electrician is correct in recommending the addition of a panel to either split or tap into the power originating from the stinger. This allows for efficient power distribution to all the equipment required for operating the restaurant. To illustrate the typical electrical service setup with a stinger and multiple subpanels, consider this layout. First, the stinger brings power to the main panel. Secondly, the main panel distributes power to subpanel 1. Thirdly, the main panel also distributes power to subpanel 2. And fourthly, the main panel distributes power to subpanel 3. In this configuration, the power from the stinger is fed into the main panel. The main panel subsequently distributes this power to the 3 subpanels. Each subpanel can then be used to supply power to different sets of equipment within the building. When evaluating the need for an additional subpanel, several factors must be considered. These factors include the total load demand, the capacity of the existing panels, and the physical layout of the electrical system. Let's delve into each of these factors. The total load demand refers to the sum of all electrical loads within the building. This includes lighting, appliances, HVAC systems, and any specialized equipment. To calculate the total load demand, one must first identify all electrical loads and their respective power consumption in watts or volt amps. Next, these values are summed to determine the overall load. It is crucial to consider both the continuous and non-continuous loads. Continuous loads are those that operate for 3 hours or more, while non-continuous loads operate for shorter durations. The National Electrical Code, or NEC, requires that continuous loads be factored in at 125% of their actual value when calculating the total load. The capacity of the existing panels refers to the maximum amount of current that each panel can safely handle. This is typically indicated on the panel's main breaker rating. For example, a 200 amp panel can safely handle a maximum of 200 amps of current. It is essential to ensure that the total load demand does not exceed the capacity of the existing panels. If it does, then an additional subpanel is necessary to distribute the load. The physical layout of the electrical system also plays a significant role in determining the need for an additional subpanel. If the existing panels are located far from certain equipment, it may be more efficient to install a new subpanel closer to those loads. This can reduce voltage drop and improve overall system performance. Furthermore, if the existing panels are already crowded with circuits, adding a new subpanel can provide more space for future expansion. When selecting a new subpanel, there are several factors to consider. These factors include the panel's opacity, the number of available spaces, and the type of enclosure. The panel's opacity refers to the maximum amount of current that the panel can safely handle. This should be selected based on the expected load demand of the circuits that will be fed from the panel. The number of available spaces refers to the number of circuit breakers that can be installed in the panel. This should be selected based on the number of circuits that will be needed now and in the future. The type of enclosure refers to the panel's physical construction and its suitability for the environment in which it will be installed. Enclosures are typically rated for either indoor or outdoor use. Once the new subpanel has been selected, it must be properly installed. This involves connecting the panel to the main panel, running new circuits to the equipment, and ensuring that all wiring is properly grounded. It is essential to follow all applicable electrical codes and regulations when installing a new subpanel. A qualified electrician should perform the installation to ensure safety and compliance. In addition to adding a new subpanel, there are other ways to address power limitations in an existing electrical system. These methods include load shedding, power factor correction, and energy-efficient upgrades. Load shedding involves selectively disconnecting certain loads during peak demand periods. This can help to reduce the overall load in the system and prevent overloads. Power factor correction involves improving the efficiency of electrical loads. This can reduce the amount of current that is required to power the loads, thereby freeing up capacity on the system. Energy-efficient upgrades involve replacing old, inefficient equipment with new, energy-efficient models. This can significantly reduce the overall load demand and improve system performance. Let's consider a practical example of a restaurant with a 400 amp service and a need for additional power. Suppose the restaurant has a total load demand of 500 amps, which exceeds the capacity of the existing 400 amp main panel. In this case, the electrician would recommend installing an additional subpanel to distribute the load. The electrician would first calculate the load requirements of the equipment that will be fed from the new subpanel. For example, the new subpanel might be used to power the kitchen equipment, which includes ovens, stoves, and refrigerators. The electrician would then select a subpanel with an ampacity that is sufficient to handle the load requirements of the kitchen equipment. For instance, a 200 amp subpanel might be chosen. Next, the electrician would connect the new subpanel to the main panel. This would involve running new conductors from the main panel to the subpanel and installing a circuit breaker in the main panel to protect the subpanel. Finally, the electrician would run new circuits from the subpanel to the kitchen equipment. These circuits would be sized according to the load requirements of the equipment and would be protected by circuit breakers in the subpanel. Once the new subpanel is installed and connected, the restaurant would have sufficient power to operate all of its equipment without overloading the electrical system. In addition to the technical aspects of adding a subpanel, there are also some important safety considerations to keep in mind. Always disconnect the power before working on any electrical equipment. Use properly insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable electrical codes and regulations. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Another important consideration is grounding. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. All electrical panels and equipment should be properly grounded. The grounding system should be inspected regularly to ensure that it is in good condition. Surge protection is another important aspect of electrical safety. Surges are sudden increases in voltage that can damage sensitive electronic equipment. Surge protection devices, or SPDs, can help to protect equipment from surges. SPD should be installed at the main panel and at subpanels that feed sensitive equipment. Regular maintenance of the electrical system is also essential. This includes inspecting the panels, breakers, and wiring for any signs of damage or wear. Loose connections should be tightened and damaged components should be replaced. A qualified electrician should perform regular maintenance to ensure that the electrical system is operating safely and efficiently. In summary, understanding the electrical stingers, main panels, and subpanels is crucial for managing power distribution in commercial buildings. When power demands exceed the capacity of the existing system, adding an additional subpanel becomes necessary. This process involves careful consideration of load requirements, panel capacity, and electrical codes. Safety precautions must be followed at all times, and regular maintenance is essential to ensure the safe and efficient operation of the electrical system. It's important to note that electrical work should always be performed by a qualified and licensed electrician. Incorrect wiring or improper installation can lead to serious safety hazards, including electric shock and fire. An electrician has the knowledge, skills, and experience to ensure that the electrical system is installed and maintained safely and correctly. Furthermore, electrical codes and regulations vary by location. A qualified electrician will be familiar with the local codes and will ensure that all work is compliant. This can help to avoid costly fines and delays. When selecting an electrician, it's important to choose someone who is reputable and experienced. Ask for references and check online reviews. Make sure the electrician is licensed and insured. Get a written estimate before any work begins. The estimate should include a breakdown of the costs for labor, materials, and permits. Do not hesitate to ask the electrician questions about the work that needs to be done. A good electrician will be happy to explain the process and answer any concerns you may have. Remember, electricity is a powerful force that can be dangerous if not handled properly. Prioritize safety and hire a qualified electrician for all electrical work. Now let's talk more about the specifics of a 400 amp service. A 400 amp service is a substantial electrical service that is typically used in larger homes, commercial buildings, and industrial facilities. It is capable of providing a significant amount of power to meet the demands of various electrical loads. A 400 amp service typically consists of a main panel with a 400 amp main breaker, which protects the entire service. The main panel distributes power to various branch circuits throughout the building. The branch circuits are protected by smaller circuit breakers, typically ranging from 15 amps to 50 amps. The size and number of branch circuits will depend on the specific electrical loads in the building. When installing a 400 amp service, it is essential to use appropriately sized conductors. The conductors must be able to safely carry the maximum current that the service is capable of providing. The National Electrical Code, or NEC, specifies the minimum conductor sizes for various ampacities. For example, NEC Table 310.15b16 provides ampacity ratings for insulated conductors. The grounding system for a 400 amp service must also be properly installed. The grounding system provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the grounding electrode to the main panel. Overcurrent protection is a critical aspect of a 400 amp service. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. Overloads occur when the current in a circuit exceeds the ampacity of the conductors. Short circuits occur when there is an unintended connection between two conductors. Overcurrent protection devices interrupt the flow of current when an overload or short circuit occurs, preventing damage to the electrical system and reducing the risk of fire. Regular inspection and testing of a 400 amp service is essential to ensure its safe and reliable operation. The main panel, circuit breakers, and wiring should be inspected for any signs of damage or wear. The grounding system should be tested to ensure that it is functioning properly. A qualified electrician should perform these inspections and tests. If any problems are found, they should be corrected promptly. Upgrading to a 400 amp service may be necessary when the existing electrical service is not sufficient to meet the demands of the building. This may occur when adding new appliances, equipment, or expanding the building. Upgrading to a 400 amp service involves replacing the existing main panel with a new 400 amp panel, upgrading the service entrance conductors, and ensuring that the grounding system is adequate. A permit is typically required for upgrading an electrical service. The permit process ensures that the work is performed in accordance with applicable electrical codes and regulations. In addition to the technical aspects of a 400 amp service, there are also some cost considerations to keep in mind. The cost of installing or upgrading a 400 amp service can vary depending on the complexity of the project, the location of the building, and the electrician's fees. It is important to get multiple estimates from qualified electricians before making a decision. The estimate should include a breakdown of the costs for labor, materials, and permits. When comparing estimates, it is important to consider the electrician's experience, reputation, and insurance coverage. Choose an electrician who is qualified, reliable, and offers a fair price. It's also worthwhile to consider the long-term cost savings associated with a 400 amp service. A 400 amp service can provide ample power to meet the current and future electrical needs of the building. This can eliminate the need for future upgrades and prevent costly power outages. In some cases, a 400 amp service may also increase the value of the building. In conclusion, a 400 amp service is a substantial electrical service that is capable of providing a significant amount of power. It is essential to install and maintain a 400 amp service properly to ensure its safe and reliable operation. A qualified electrician should perform all work related to a 400 amp service. Furthermore, consider the possibility that the equipment is not being used at the same time and therefore not demanding 400 amps at the same moment.